Welcome. If you're interested to learn how to find the area of an inscribed triangle within a circle with a radius 5, well, I'm going to show you step by step and explain coming up right now. Welcome, my name is Brian McLogan, and I want to show you how to do this problem. But before I get started explaining my thought process, what I want you to do is just spend about 5-10 seconds and start writing down all the things you know about this problem, and then we'll go ahead and compare. Okay, welcome back. So hopefully you got some things down, and what I'd like to do is just kind of explain what exactly I was doing as I started thinking about the problem. So, a couple things I noticed. So we were talking about the area. So, first thing I looked at, well, the area of a triangle is 1/2 base times height. And it doesn't really matter what type of triangle we're looking for. We want to find, the length of the base, and we want to be able to multiply that times the height times 1/2. The next thing, another thing I looked at was, equilateral. Well, an equilateral triangle has equal side lengths as well as equal angles. So they're all going to measure 60 degrees because the angles of a triangle add up to 180. So divide that by 3 and we get 60 degrees. The next thing is I just started thinking about, well, if we're trying to find the height here, when I took this equilateral triangle and I drew the height, I kind of cut this 60-degree angle and I gave it 30 degrees. And then that kind of prompted me, well, if that's 30 and that's 60 degrees, well, I just created a special right triangle, the 30, 60, 90 right triangle. So that's what I did right here. And if we remember the relationship of a 30, 60, 90 triangle, so I kind of did that over again. I just kind of flipped it around and said, all right, well, if we take an equilateral triangle, break it up in half, this is still the height, but then we have a 30 degree, 60 degrees. So how is the relationships related for a 30, 60, 90 degree triangle? And one way to easily kind of look at that is, let's say this is 30 degrees, this is 60 degrees. The relationship basically kind of goes like this. If this is going to be x, then this is 2x, and then this is going to be x times the square root of 3. That's like the basic relationship if, given our short length is going to be x. So in this case, though, if we kind of look at this triangle, so we know this is 60 degrees. If I break this up here and I create this as my angle, what we can see, actually, let's do it this way. Let's do it on the other side. If I take this one out, what I'm given now is given my length of 5. So what that means is my short length, instead of going from the short length to the hypotenuse multiplying by 2, I'm going from the hypotenuse to my short length. So therefore, this is going to be 5/2. That's where I came from here. And then whatever your short length is, you just multiply that by the square root of 3. So I just took my short length and then multiplied by the square root of 3, and then I got this area. And that kind of looked into that. That kind of helped me out because if I can find the area of one of these triangles, well, I can just figure out how many of those triangles I have to find the area of all of the circle. So let's kind of take a look at this, because if we have this triangle, we can orient this triangle any way we want to. Again, we could think about this as, okay, so if we said then this was 5/2, we don't really care about the hypotenuse for the area, 5 square root of 3 over 2. If I want to find the area of this triangle, the area is equal to 1/2 times 5/2 times 5 square root of 3 over 2, right? So 1/2, height times base, or we could rewrite it base times height. Doesn't really matter which order we multiplied in. But therefore, I could find the area of one of these triangles, particularly this triangle. I can find the area just by using my special right triangles. So when I go ahead and multiply this out, I get 25 square root of 3 over 2 times 2 times 2 is going to be 8. So again, that's one triangle, but I got to figure out how many of these have. Well, when I broke this triangle up, you can see that I can create 1, 2, 3, 4, 5, 6. So then if the area of one triangle is this, all I got to do is multiply by 6 to find the area of the whole triangle. So I'm just going to multiply this by 6. Now, rather than multiplying 25 times 6 and then dividing that by 8, that could be a little too crazy for me. So what I would do is let's just go ahead and reduce our 6 over 8. So if I reduce the 6 over 8, I can divide the top and the bottom by 2. So if I divide 6 by 2, I get 3. If I divide 8 by 2, I get 4. Now, that creates a little bit easier multiplication for me. I'll put the 3 in front times 25 square root of 3 over 4. Excuse me. Now I can just do 3 times 25, which is going to be 75 square root of 3 over 4. So there you go, ladies and gentlemen. That is how you find the area of an equilateral triangle inscribed within a circle when you're given a radius. I hope you enjoy. I look forward to helping you on the next one. And if you have not already subscribed, I would love to have you. This video was brought to my Patreons on patreon.com, as they are really giving me the opportunity to create more videos like this. So I hope you enjoyed. Again, subscribe, and then let me know what you'd like to see more of down in the comments below. Cheers.